You've probably heard about the blockchain. Maybe you've even bought some Bitcoin or Ethereum. But how does the blockchain actually work? In this episode, we're going to break down what the blockchain is and why it matters, using day-to-day words for easy understanding. If you're just learning about our channel, you may want to check our previous video for a full explanation of what the blockchain is. Today, we are discussing how it works. But why the blockchain? First, blockchain is one of the foundational technologies of the internet, and it's really important to understand how it works. Second, we think that the future will require a certain level of digital literacy, and we want to help you get ahead of the curve. So let's get started. So how does the blockchain work? Well, it depends on what you're actually trying to accomplish with it. Blockchain itself is just a type of database. It's a way of storing information in a particular way. So to explain how it works, we're first going to need to talk about databases, starting with how most databases work. In a traditional database, all of the data is stored in one place and can be accessed and modified very quickly. For example, when you buy something at the grocery store, the cashier scans the barcodes on the products you're buying. Each barcode contains product information, like the product ID, price, and the description, which is then sent to the computer, which rings up your order. The computer stores this information in its database, and if you ask it to, it can retrieve that information for you. But there are problems with storing all of your information in one place. One problem is security. If someone hacks into the system, they can steal or modify your data. You might have seen headlines about databases being hacked and people's personal information being stolen. That's a big problem. Another problem is trust. Imagine you're running a business and you hire someone to run your social media accounts. You trust them to post interesting things on your behalf, but you also don't want them to make changes to your customer database. Traditional databases require you to trust the organization that built them to protect your data. But what if the database was built in a different way, one where no single person or organization had control over it? What if it was decentralized? That's the idea behind blockchain. In a blockchain, the data is distributed across multiple computers. Instead of storing all of your information in one place, it's stored in many places, making it much harder to hack. In fact, it's impossible for a hacker to gain access to a blockchain by hacking into just one computer. They would need to hack into every single computer on the network. Now, that doesn't mean that blockchains are totally secure. More on that later. Okay, so why stop there? Why not store the data in an even greater number of places? This brings us to the next key feature of blockchains, namely their size. As blockchains grow, they become larger and larger. There is no limit to the amount of data that can be stored in a blockchain. The more users there are, the more data is generated, and the larger the blockchain becomes. But because a blockchain has a finite width and height, the older blocks of data become compressed and harder to access. However, because each block contains cryptographic information that allows it to be verified, the integrity of the entire chain is maintained. Now that we know what a blockchain is and some of its features, let's look at how it works. Blockchains work using cryptography, which is the use of algorithms to keep data secure. In a blockchain, each block of data is encrypted using public key cryptography. Public key cryptography uses pairs of keys, a public key, and a private key. Your public key can be given to anyone, while your private key should be kept secret. If someone sends you encrypted data using your public key, only someone who knows your private key can decrypt it. In the case of a blockchain, the public key is used to verify that the data is correct. Then the private key is used to encrypt the data and add it to the blockchain. This ensures that the data is both secure and tamper-proof. Another key feature of blockchain is consensus. Because blockchains are decentralized, there needs to be a way to ensure that everyone agrees on what data is stored in the blockchain. Consensus is achieved through a process called proof of work. Proof of work is a way of verifying that a block of data has been added to the blockchain correctly. To do this, each computer on the network runs a cryptographic algorithm. The first computer to complete the algorithm's equation adds the next block to the blockchain. This ensures that everyone agrees on what data is stored in the blockchain. Finally, we need to talk about smart contracts. A smart contract is code that can be used to create new blockchains. For example, Ethereum is a blockchain that was created using the Ethereum Virtual Machine, or EVM. The EVM is a computer that runs the Ethereum blockchain. It contains the rules for how transactions are validated and executed. Smart contracts can be used to create new blockchains with different rules. For example, Hyperledger Fabric is a blockchain that is optimized for enterprise use. It allows multiple users to write smart contracts and deploy them on the blockchain. One thing to note about smart contracts is that they are not legally binding contracts. Rather, they are pieces of code that can automate complex agreements. All right, now let's talk about some applications of blockchain outside of cryptocurrency. As we mentioned earlier, blockchain is just a type of database. It's really just a way of storing information in a particular way. So it can be used for anything where you need to store information securely and efficiently. For example, blockchain can be used to store medical records, voting records, or even supply chain information. In fact, any industry that deals with a lot of data and transactions can benefit from using blockchain. Now, despite all of these benefits, there are also some challenges associated with blockchain. One challenge is scalability. As we mentioned earlier, blockchains can be slow and expensive to use, especially when there is a lot of activity on the network. Another challenge is regulation. Regulators are still trying to figure out how to deal with cryptocurrencies and other blockchain-based products. And finally, there is the environmental impact of mining. Mining is the process of adding blocks to a blockchain. It requires a lot of energy, which can have a negative impact on the environment. Despite these challenges, we think that blockchain is an important technology to understand. The future will require a certain level of digital literacy, and we want to help you get ahead of the curve. Let's take a minute to recap some of the key takeaways from this episode. First, we learned that blockchain is a type of database that stores information in blocks that are linked together in a chain. Each block contains a timestamp and a link to the previous block, creating an immutable record of data. Second, we explored how blockchain works. We learned that it uses cryptography to secure data and consensus to ensure that all users agree on the data stored in the blockchain. Finally, we discussed some of the challenges associated with blockchain, including scalability, regulation, and environmental impact. We hope you enjoyed this episode of Understanding Blockchain using day-to-day words. If you did, you can let us know by giving this video a like and subscribing to the channel. You can also leave us a comment or question, and we'll see you next time. Thanks for watching this episode. See you on the next one.